They look outlandish, move unpredictably, and often live in shadows, waiting to ambush unsuspecting prey. Spiders reliably rank among the animals that provoke the most fear and disgust, alongside scorpions and other arachnids. Their appearance feeds both. 8 legs spread around a body with no face we instinctively understand, no neck, no antennae, no familiar expression. We struggle to see where a spider is looking or what has attracted its attention. The legs dominate its outline. The central body may be small, but 8 widely spread limbs make the complete animal appear much larger. Body hair, prominent fangs, and a swollen abdomen intensify the reaction. Studies using altered spider images have found that these features increase reported fear and disgust. This visceral reaction changes what we see. People who fear spiders tend to judge them as larger and less controllable, and that exaggerated appearance strengthens the fear. But not every spider produces the same response. Jumping spiders are often perceived warmly. Their 2 large principal eyes face forwards, forming something close to a recognizable face. They turn to inspect objects, appearing curious, and move in short, deliberate bursts. Most spiders reveal much less. Their eyes are small or difficult to distinguish. Their mouthparts sit beneath the head, and their legs obscure the direction of the body. Then they move. A spider can remain motionless for hours before accelerating instantly. It can run forwards, backwards, or sideways, climb straight up a wall, cling beneath a ceiling, or descend through empty space on a thread of silk. An animal normally turns its head and body before changing direction. A spider already has legs extending around almost its entire body. It can reverse course with little preparation. This movement looks unnatural because the machinery behind it is unlike our own. Humans move a joint using opposing muscles. One set pulls it in one direction, another pulls it back. Several important joints in a spider's legs lack extensor muscles. The spider helps straighten them by increasing the pressure of the fluid inside its body and legs. Flexor muscles then pull the joints inwards again. When a spider dies and can no longer maintain this pressure, the legs curl beneath its body. Muscles and elastic structures also contribute, particularly during fast running and jumping. Spider movement is not purely hydraulic, but internal pressure remains an important part of the system. The movement looks alien because it is produced by radically different engineering. This has encouraged a simple explanation for spider fear. Venomous spiders threatened our ancestors, so humans evolved fear of them. The evidence points to something subtler. 6-month-old babies show greater pupil dilation when viewing spiders than when viewing matched images of flowers. Spider shapes capture our attention very early in life, but widened pupils reveal arousal and attention, not necessarily fear. Adults can also locate spiders quickly among other images, although the advantage is often strongest in people who already fear them. Humans do not need a dedicated spider alarm. We already pay attention to sudden movement, crawling animals, unfamiliar bodies, and creatures capable of biting or stinging. Spiders combine all of these signals. We may therefore be prepared to notice spiders and prepared to learn that they are dangerous. That is not the same as being born terrified of them. Experience and culture build upon the initial reaction. A child watches an adult recoil from a spider. They hear spiders described as dangerous or disgusting. Webs warn that something is lurking nearby. Someone does not need to be bitten to develop spider fear. They can learn it by watching the people around them. The strength of this fear also varies between individuals and cultures. What looks like pure instinct is a mixture of heightened attention, learned disgust, cultural expectation, and personal experience. But spiders have not gained their sinister appearance by accident. They are built to hunt. Even the hairs covering their legs are part of a sophisticated sensory system. Fine hairs called trichobothria respond to tiny movements in the surrounding air. Other sensory structures detect minute strains passing through the legs and exoskeleton. A spider can feel movement through the ground, a leaf, or a strand of silk. For a web-building spider, the web extends this sensory system into the surrounding environment. Each thread carries information. Wind produces one vibration. Struggling prey produces another. An approaching mate must send the correct signal or risk being mistaken for food. Some spiders adjust the tension of their webs, changing how vibrations travel through them. Orb webs can even respond to airborne sound. Sound moves the silk, and the resulting vibrations pass into the spider's legs. The web is not merely a trap. It is an enormous external sensory organ. The spider sitting motionless at its center is monitoring the entire structure. Jumping spiders rely more heavily on vision. Their large principal eyes provide detailed sight, while their secondary eyes watch a much wider area for movement. They can track prey, judge the distance of a jump, and choose indirect routes towards a target. Some can begin a detour by moving away from visible prey, lose sight of it, and still arrive at the correct location. The spider may be difficult for us to understand, but it understands its own world with extraordinary precision. Almost all spiders possess venom, evolved to immobilize the small animals they prey upon. More than 50,000 spider species have been described. Only a small number pose a serious medical threat to humans. At the scale of an insect, however, spider venom is devastating. The fangs puncture the prey and inject compounds that attack its nervous system or tissues. Digestive fluids begin breaking down the victim outside the spider's body, and the spider consumes the softened material. It does not simply drink the blood or suck out a perfectly liquefied interior. It repeatedly applies digestive fluid, manipulates the prey, and ingests liquids and tiny particles. Silk makes this hunting system even more versatile. Spiders use it to restrain prey, build shelters, protect eggs, communicate with mates, and create safety lines. An orb web is only one possible design. Trapdoor spiders dig burrows, line them with silk, and conceal the entrance beneath a hinged door of soil and vegetation. Silk trip lines radiate across the surrounding ground. When an insect disturbs them, the spider detects the vibrations, bursts from the burrow, and drags its prey underground. Ogre-faced spiders take the opposite approach. They hold a small web between their front legs and throw it over insects passing beneath them. Bolas spiders hunt through chemical deception. They release chemicals resembling the sex pheromones of female moths. A male follows the scent, expecting to find a mate, and the spider catches him with a sticky ball of silk. Then there is Portia, a jumping spider that hunts other spiders. Portia enters a web and plucks its threads to create false signals. It can imitate trapped prey or a courting mate, drawing the resident spider closer. If one signal fails, it tries another. These spiders stalk, deceive, and adapt their behavior to different prey. They are not simply waiting for food to blunder into them. Rather than employing variations on a single hunting method, spiders have evolved into many radically different predators, all built from the same basic body plan. Together, spiders form one of the largest predatory forces on Earth. A global estimate puts their annual consumption at between 400 and 800 million tons of prey. Most of it consists of insects and other tiny animals. Across forests, grasslands, deserts, caves, and human homes, spiders are constantly hunting. So why do they frighten us? They combine an unfamiliar body, sudden movement, hidden sensory abilities, venom, and the possibility of unwanted contact. Our attention detects them. Disgust wants them away from our skin. Experience and culture turn discomfort into fear, and fear inflates the spider to appear larger and more dangerous than it really is. For humans, most spiders are small, vulnerable animals with no reason to attack us. But our fear is not based entirely on fantasy. We recognize the shape of a predator. We see the legs, fangs, stillness, and the sudden attack before considering whether we are the prey. Our fear detects something real. It simply applies it at the wrong scale. Spiders are not particularly dangerous to humans, but when we see one, it is often from the prey's point of view.